So today we're going to do a couple of small examples with significant figures, and then formally talk about bounds that I've been talking about, but haven't really formally discussed them. So let's first start out with some simple examples. Let's take the first example. Let's say we have a number like 8,982, and you want to round off to two significant figures. So if I want to round it to two significant figures, please note that these are the two significant figures, and they are both significant. Why? Because these are non-zero digits. So I have to look at the next digit, which is an 8, and the 8 is greater than or equal to 5. So this 8 is greater than or equal to 5, which means I have to round up. So if I round up 89, so if I round up this 89, which I have right over here, if I round up this 89, it's going to turn into a 90, and the answer is going to be 9,000. So this is up to two significant figures. Now you can see, as we said earlier, if you see an answer like 9,000, you don't know whether it's rounded to one significant figure, two significant figures, three significant figures, or four significant figures. It turns out that in this case, it's rounded to two significant figures. Let's take another example, maybe like 0.006 0195, and I want to round it to four significant figures. Now please note that the zeros are coming in different flavors. These zeros are not significant. They're not significant because they're not preceded by a non-zero digit. Okay, and this was rule number 3 that we studied, which was in a decimal, all zeros before a non-zero digit are not significant. But this zero, which is sandwiched between two non-zero digits, is significant. Okay, so now we're going to count the number of digits that we need. So we need four significant digits. So this is the first one, this is the second one, this is the third one, this is the fourth one. So these are four significant digits. So in order to now round it, I have to look at the next number, and the next number is 5. So that means I have to round up. When I round up 19, I'm going to get 20. So the answer is going to turn out to be equal to 0.00602. Okay, now this 0 is important. This 0 you can't get rid of, because this 0 is saying that I have four significant digits. So if you did not write this 0 and you wrote it without this 0, so if you wrote it in this way, this would only have three significant figures. The 602 are significant. So in order to get it down to four significant figures, you have to write down the 0, and the 0 is significant because it is in a decimal, and we already know that our rule number 4, which was all decimal, in a decimal, all zeros after a non-zero digit are significant. So this would be a significant. So this 0 is significant. Okay. So let's try another one. Last one. Let's look at a number like maybe 0.9999, and I want to do it to three significant figures. Well, if I want to do it to three significant figures, well, you can see that these three nines are significant. These three nines are significant. So I have to look at the fourth 9. The fourth 9 is right over here. So this 9 is greater than or equal to 5. That means I have to round up. If I'm going to round up, all the 9s will get converted into zeros. So I'm going to get a 1, but the answer is really going to be not 1, but 1.00, and this is true to three significant figures. If I only wrote down 1.0, this would be two significant figures, but I need three significant figures, so I have to write down 1.00, and these two zeros are significant. They are significant because of our rule that in a decimal, all zeros after a non-zero digit are significant. That was rule number 4. Okay, so now what I want to do is very quickly talk about some bounds, and let's think about how do we want to um, think about bounds. So if you have a number like 14.5, so I have a number like 14.5, okay? So what was the actual value to, let's say, if I want to think about to two decimal places? Well, if I want to think about it to two decimal places, then the actual value could have been 14.46, because when I approximate, let's say, so what was the actual value? The actual value could have been 14.46 to two decimal places. Sure, because when I round off 14.46 um, to one decimal place, I'm going to get 14.5. It could also be 14.52. So what's the maximum it could have been to two decimal places? Well, the answer is that if I say that x is equal to 14.5, then I know that x would be less than 14.55 if I'm thinking about two significant. So this is less than, okay? And it would be greater than equal to 14.45, okay? And this guy is called a lower bound for obvious reasons. So this is called a lower bound. And this is called an upper bound. Now, and also remember, for an upper bound, this has to be less than 14.55, because if x were, for example, if x were actually equal to 14.55 and I want to round it to two decimal, if I want to round it to one decimal place, I would look at this 5, this 5 right over here, and this would mean I have to, so this number is greater than or equal to 5. So when I approximate it, this would turn out to be equal to 14.6 to one decimal place, okay? So since it is not, that means I can't have it equal to 14.55. It has to be less than 14.55. So it could be like 14.549999999, and that would be perfectly fine, okay? So now